presentation without a laptop, without anything. This is a Brazilian way of doing stuff, but we will help him, I hope, in 1 second. Leonardo is a friend. He arrived here many years ago in the Cavagna lab, and was lucky enough to work with Giovanni Cavagna. Okay, it works. So it works like this. You have to push this to go ahead. If you want the pointer, you use this as a pointer. It is like in Brazil, but this is Italian way. Okay. Leonardo PEYRÉ-TARTARUGA, Professor Leonardo PEYRÉ-TARTARUGA from the University of Pavia. But where your family was from?
La Spezia.
La Spezia, okay. So he's from Pavia, the university. Grew up in Porto Alegre, but the family was from La Spezia. And accordingly to our tradition, we will discuss something about locomotion finally. We go out from the cycling, we go to the locomotion. Mechanical determinants of energetically optimal step frequency at gradient. Leonardo, 8 minutes, nothing more.
Oh my, that's not a dual task, it's a triple task. Good night, thank you so much, Gaspar, for the introduction. I'd like to thank you, the Professor Alberto Minetti also, for the invitation. Okay. It's not here. Just to remember good moments in Brazil. And I would like to thank you strongly in many things. One that's a very important point. He allowed me to come here 20 years ago to work together with me, Professor Alberto and Professor Cavani. And I would like to make a simple, humble tribute to him, because we have 1 year that he passed away. My respects to our great professor, amazing master. Okay. Tonight I will present you preliminary results of our project, titled as the mechanical determinants of self-selected step frequency at uphill walking. Our idea in general was extending the studies from Cavani and Minetti, where they test the effects of the step frequency at same speeds, and then also at different step lengths, but not just during level, also at uphill. And testing that, we try to test one very important aspect of the pendulum-like mechanism in walking, that is the inevitable task to walk upstairs. As we see our friend here, Gaspar, upstairs, downstairs, here. Trying to test with this inevitable task schedule to change that optimization that happens at level. Okay, I will show now. We know that at uphill walking we have also optimal speed, lower than at level. No, but we don't know with the product of the step length and frequency is optimized at self-selected conditions. At level, we have two studies, experimental studies from Cavani and Franzetti, 1986, and Umberger, 2007, where they showed that the self-select step frequency occurring at lower speeds in terms of mechanical power. And we have a very interesting theoretical study from Saiveri-Minetti, 2002, where they show 2009. And we see that the minimal power, mechanical power occurring exactly at the self-select step frequency. And then our research question is, are the self-select and optimal step frequency are similar? If so, the generation of mechanical work may account for this optimization at the beginning. Our main objective was comparing the metabolic pulse mechanical work, pendulum-like parameters, and the gate biomechanics at different step frequencies in level and field. And also we try to test the promotion or model by Margarita Minetti to try to explain this optimization, as I will show you. We have data from just two people, two adults, young adults, aging 23, and our experimental protocol was warm-up and walks at 5 minutes at level, walking at 4.5 kilometers per hour and uphill 3.5. I will show you some results here. We confirm the optimal speed at gradients, as you can see here. The step frequency, optimal step frequency here. The respiratory frequency was lower at self-selected than below and above step frequency. And most importantly, the mechanical determinants was very important to find the self-selected speed. Where, as you can see, with pendulum-like higher at self-select than below and higher at W. Then we find also the optimization using the external and internal work. I will pass rapidly. Then we confirm the model proposed by Minetti et al. 1993 and Margarita firstly 1938. Very classical word, hour, and we conclude that the optimization happens at the hill walk, and the mechanical work is very important. The quantity of mechanical work and their respective mechanical efficiencies. Thank you so much.
Well, thank you, Leonardo. So, questions? Thank you, because you finish in time. You are here since this morning at 8:30 and you didn't understand yet the ding ding ding. Come on. Questions? Okay, so I have one. But just because I went out and I'm back, so I missed one part. how did you calculate the mechanical work and the energy recovery?
Yes, sorry. We use the mockup system. Slowly. Yes. Are you prepared? Then using the open cup system. And I had two data, and from 48 hours ago, I was working crazily with this data. It's not easy, and this data is from 3 cycles, stride cycles in 2 cases, and the others 20. And then it's not easy using that system.
Okay.
After I will explain in the case.
So
I need to work a lot.
The last question is, are the values similar or not to what is in the literature at least?
Yes, it's very similar to the conditions, except at the force of reference at that field. But comparing to the normal, it's very, very similar and using minutes studies. Not so much.
I'm surprised, I would say, surprised. Positively surprised that something comes out rightly.
But a huge work.
Of a huge work of smoothing.
We are using the open cup, not the free systems that maybe in person free system proposed by Scott Delp from Stanford University, but it's not.
But the center of mass is not validated.
No.
And you want to do energetics of the center of mass from motion?
Okay. We just compare with P-Vicon.
Okay.
We know.
Any other question? May I have the second one? Which efficiency did you place to the internal negative work? Which efficiency did you use for the negative internal work?
Accepting the negative and positive words a little bit different from Minetti et al. 1993. We include that. That's not change at 7 at the maximum percent of the estimatives of the theoretical cost. No.
But the internal work has the same or different efficiency in positive and negative?
We use the same constants, 1.25 and 0.25.
Perfect. Would you use a different efficiency for internal mechanical work, positive and negative? I would suggest no. But it's a Minetti thinking, this one, and he's just outside. So.
That's great.
For the internal, I think it's the same. It's not different.
In Minetti et al. 1994, for the running, they changed the
But you are doing walking.
Yes.
You are doing walking.
And in walking, they don't.
Yeah. Okay. Okay. So, thanks to Leonardo.